Hello, my name is Wes Gardner. I'm an architect in the product marketing division here at Nemetschek North America, the creators of Vectorworks. I'd like to take this opportunity to show you how to gather information from a data model and how this data can be used to populate a report or worksheet. Utilizing a BIM or Building Information Modeling workflow, the data can be used not only by you as the architect, but by the general and subcontractors as well. We'll go a little beyond the pre-formatted door and window schedules that ship with Vectorworks and show you how to gather data and produce a variety of reports and quantity takeoffs. I'll use this little farmhouse as an example and some of the modeling and reporting tools available in Vectorworks that are tailor-made for this purpose. As you'll see, some of the information can be obtained from pre-formatted reports within Vectorworks that we'll then modify to produce the data we're looking for. And in other cases, we'll start from scratch, creating a record format from which the data will flow to a worksheet, generating the report we're after. A couple of items for clarification. There are two types of objects within Vectorworks. Those that have already been created and have record information associated with them, like doors, windows, and cabinets, and those objects that you create and attach record information to them. We'll explore both. So in this exercise, we'll calculate the amount of concrete required for the footings, total up the number of concrete block required for the foundation walls, list the number of railing posts for the porch, and lastly, quantify the number of recessed lighting fixtures in the project, and explore energy savings by switching from one type of lamp to another. So let's get started. To calculate the amount of concrete for the footings and create a takeoff similar to the one shown here, I'll start here with a plan view of the footing and foundation system of the house, and we can take a look at it in 3D so you'll have a better idea of the project. You can see several widths of footings and a larger spread footing where the fireplace will bear. Each footing width is a separate wall style, and I'll explain that in a little bit. Let's take a look at the layer settings for this project. I've created a discrete layer for the footings for a number of reasons. I can control the Z height easily, and I can also control the visibility of the layer. Let's also take a look at the class settings as well. I tend to class just about everything, believing that this methodology provides the most control over how my model and subsequent views in the sheets will look. So let's run a wall report on the footings. Since I've used walls to create the footings, I can run a wall area report, one of the pre-formatted reports available in Vectorworks. And from this report, I can derive all the information I'll need to get the number of yards of concrete in the footing. Keep in mind that any report is completely coordinated with the data model, so if you change the design, it will be reflected in the report. So here we have a wall quantity report, and what I'll do is format the data to get the results I'm after. First, we'll limit the report to just footings. I do this by entering the criteria in the database header row, asking Vectorworks to just report on walls that have a function of footing. I set that criteria when I develop my wall style under the Data Fields tab in the Wall Preferences dialog. Okay, perfect. Now, as you can see, the report generates several columns of data. The column labeled Mark would most likely be used in a commercial project for wall types. Here we don't need that column, so I can eliminate it. In this case, the two columns displaying area, area gross, and area net are both the same. So I'll just reuse the column area net and move it and type in a formula to calculate cubic yards. I'll need to write a little equation that converts cubic feet to cubic yards, and then, with a few formatting touches, we have a table that calculates the number of yards of concrete in the footings. Okay, I like it. I'll just add another formula down at the bottom that takes the total number of yards and multiplies it by the cost. In this case, we'll use $65 a yard. And with a little additional formatting, such as adding a dollar sign as a leader and maybe making the font size a little bigger. We have a cell in our worksheet that shows a dollar figure associated with the quantity of concrete. So I'll complete the formatting and move my newly made table under the example so we can take a look at how the model and the table or worksheets are linked. And as you can see, the table is interactive. As I stretch one of the footings out and in essence add more material, when I recalculate the worksheet, that increase is reflected in my material takeoff. Now let's take a look at totaling up the number of concrete block required for the foundation walls. In this project we have two sizes of block, 8-inch and 12-inch, and three types of walls, two utilizing the 12-inch block and one that uses the 8s. We'll use the wall area report again and modify it to yield the quantity of block required for the job. Okay, I have three partially completed worksheets we'll use and modify as we go along. First we'll run the wall area report and we'll limit its search to all the walls on the foundation layer. And you'll see our three wall types that I defined at the beginning of the project. I've got 12-inch block veneered, 12-inch block parged, and 8-inch block veneered. These wall types were developed from the default content that ships with the program and just renamed. I also gave each wall type a discrete designation. You can see those under the Mark column. So now I'll go back and further limit the search criteria to just the 8-inch block. In fact, I'll use that Mark designation as a means to limit the search. Okay, perfect. And now, having done a little math behind the scenes, I know that one block equals approximately 0.89 square feet of surface area. We'll use this to write a formula that calculates the quantity of 8-inch block. And I'll enter that formula into my pre-formatted worksheet that will give us the number of 8-inch block on the job. Okay, hey, that looks good. Okay, and now let's go over and look at the 12-inch block. We can do a similar search and limiting of the criteria to find just the 12-inch parged block, which I've done here. In the interest of time, I won't go through the process step by step. It's the same as for the 8-inch block. The last worksheet totals up all the 12-inch block on the project. It has a little trick embedded in the worksheet that links the data from the 12-inch parged block worksheet and pulls it into this one. It then adds both quantities together and divides by 0.89 to get the total number of 12-inch block. All of this data could then be pulled into a bill of materials for further evaluation by the design team. Now we'll take a look at attaching data to a record and how we can then produce a worksheet or bill of materials from that. So first we create the record format. This defines the individual data fields for the record and provides a path for the data to flow from the data fields in the object info palette we'll see in a minute to the worksheet. We go to the resource browser and choose record format, whereupon we're presented with a dialog box where we can start defining those data fields, such as the manufacturer, the location of the object, the size, and maybe the color. As you can see, the fields can be text or numeric and can be formatted as required simply by selecting the appropriate type and entering the default information if desired. I've only created a very basic list for this demonstration, but this will give you an idea of how to do it. From here you can build up an entire library of worksheets, using them again and again in your project, and developing a complete bill of materials that will satisfy any contractor, consultant, or owner. We can now see that the record format has been created in the resource browser, and we're now ready to attach data to an object. So I'll pick one of my railing posts, and up in the Object Info palette we can see I've selected a hybrid object. And now under the Data tab, I'll select the record format I want to attach the data to. In this case, it's called Post Counter. In the pane just below the list, we can see those data fields I originally created. Here's where I enter the required data. I'll enter the manufacturer's information and hit Return to move to the next field, entering location, then the size, and finally the color, which I don't know yet. We'll be able to go back and change this once that's been decided. I can then move over to another post and repeat the same thing, entering manufacturer's information, location, size, and color, knowing that this information is being tracked by the database within Vectorworks. I mentioned that the information can be input now or later. This is again part of the flexibility of Vectorworks. If you make a mistake or omission, no problem. You can edit the data at any time. So to see this data, I'll need to create a worksheet that can then be formatted and turned into a bill of materials. Or I can link the worksheet to another to create a master bill of materials for the entire job as described earlier. So I'll create the report for the railing post information that I entered earlier. In this case, I'm looking for the record called Post Counter. Once the report is made, I can go back to my drawing and further populate the worksheet with additional data by entering the information into the data fields in the Object Info palette. As mentioned, this can be done at any time once the record format has been established. So now I'll go back and choose the post counter as the record I want to add additional data to. And once again, I can enter the required data, hitting Return to move to the next field. I can add my manufacturer's spec and then go on to location, and finally the size of the post, and as I mentioned earlier, the color, which we still don't know, but that, like I said, can be added at any time. Once all my data fields have been filled, I can go to the worksheet and hit Recalculate to see the change. As I mentioned, data can be attached to any object, and as you can see, this can be accomplished in a 3D view, as I've done here, or a more conventional plan view. Okay, so now that we know how to attach data to objects, let's take a look at a practical application. Here's a reflected ceiling plan of the farmhouse. I'm showing a couple of different types of electrical objects. Those that came from the library that ships with Vectorworks, and those I've created to get just the look I want. I'm using a slightly modified version of the electrical device schedule that ships with Vectorworks to allow me to count and itemize the types and quantities of devices I place in my drawing. I can then go back and edit the information to show how I might save some energy using compact fluorescent lamps rather than incandescent. We'll be able to see the number of watts decrease as I swap out the lamps, but also we should consider a decrease in cooling loads as well. I'll use a script to select all the recessed downlights on both the first and second floor, and by changing the number of watts used in the data pane from 100 watts down to an equivalent in compact fluorescent of around, let's say, 25, when we recalculate the worksheet, we can see we saved around 1300 watts. And furthermore, as you can see, this schedule also counts the number of switches and receptacles on the project, and therefore could also be linked into a master bill of materials. In conclusion, we've seen just a couple of examples of how to use the reporting and worksheets built into Vectorworks. With these, we're able to gather and share information in a coordinated and accurate manner once the data model has been built.